Good morning everyone. So in the previous class we had done till question number 2. Okay, I had done the first one, the remaining were homework for you. Now let us see the question number 3. Okay, so question number 3 also u and v. Okay, u into v, you can use that. So let me write the question over here. So question 3.1, let y is equal to 2x minus 3, 4x minus 5. Now I have to differentiate this. So here this one is your u, this one is your v. So we will get 2x minus 3, 4x minus 5 upon dx plus 4x minus 5, 2x minus 3 dx. 2x minus 3. Now here this is 4x minus 5, you can differentiate it. Okay, you can do it in mind. So you will get 4. Okay, because for differentiation of 4x is 4 and 5 is constant, so 0, so you simply get 4. So this will be written in multiplication, and here 4x minus 5, and if you differentiate this 2x minus 3, you will get simply 2. So right over here. Now you can open the bracket, so you get 8x minus 12 plus 8x minus 10, so 16x minus 22. This is the answer. Now see the next question, question 2. So here you can see that 3 functions are in multiplication. Okay, let's say this is u, this is v, this is w. Okay, so what we will do is, firstly we will consider this whole thing, this much as u and this as v. Okay, then we can use u into v. See over here, dy upon dx is equal to, I will keep u outside, so x to the power 5, and then here e to the power 2x into log x plus, now keep this v outside, and x to the power 5 dx. Done. Now you can see for this you are getting again u into v type. Okay, so we will have x to the power 5, and for this, okay, for this we will use the product rule, so we will get e to the power 2x log x plus log x e to the power 2x plus e to the power 2x log x, and differentiation of this x to the power 5, you will get 5x to the power 4. Done. In the next step, x to the power 5 e to the power 2x, differentiation of log x will be 1 by x plus log x, differentiation of e to the power 2x. So firstly you think this whole thing as x, so you get same thing, e to the power 2x, then differentiate 2x, you will get 2. Okay, close this bracket. So here 5x to the power 4 into e to the power 2x into log x is equal to, here you can open this bracket, so this x will cancel over here, so you get x to the power 4 e to the power 2x plus 2 into x to the power 5 into e to the power 2x into log x plus 5 into x to the power 4 into e to the power 2x into log x. Here you can see that in each term you can see e to the power 2x is common, so e to the power 2x comes out, then x to the power 4 is also common, so you are left with 1 plus 2x log x plus 5 times log x. This is the answer. Okay, so I have done these two for you, number 1 and number 2. This will be your homework. Okay, now let us see question number 4. So in question number 4 we have to use quotient rule, because you can see this is your u and this is your v, so u upon v. Okay, so let us see. Okay, see this question. So question number 4.1, here question is y is equal to x square upon e to the power 3x. We have to differentiate this with respect to x. So here this is your u and this is your v. You can see over here, okay, you have to recall this. Okay, you have to recall this. This is the quotient rule. Okay, so using this quotient rule we will differentiate this. So see over here, dy upon dx is equal to, I will write the function x square upon e to the power 3x. Now this denominator is your v and numerator is your u. Okay, so you know that if you have u upon v, then you get v du upon dx minus u dv upon dx upon v square. So here we will get e to the power 3x then dx square upon dx minus x square d e to the power 3x upon dx whole divided by e to the power 3x whole square. So using this, yes, now you get e to the power 3x. Now you know differentiation of x square will be 2x minus x square. Now differentiation of e to the power 3x, you know differentiation for e to the power x, that is e to the power x. Here you have got m, here you have 3, so you have to consider this whole thing as x. Okay, so if you consider whole thing as x, then you'll get e to the power 3x and then differentiate this 3x, so you'll get 3. Okay, and down here e to the power 3x whole square. Yes, so that means leave it like this right now, because I can see in the numerator I am going to get e to the power 3x common, so later on I can cancel it. Yes, so leave it like this. Now in the numerator e to the power 3x and x is common. Okay, so you are left with 2 minus 3x, and here e to the power 3x into e to the power 3x, because square is there. Okay, and then cancelled. Okay, so equal to x time in bracket 2 minus 3x, and here you get e to the power 3x. So this is the answer. Okay, that is, this is the derivative. Okay. Okay, so question number 1 is done. The remaining 3 questions, homework. Okay. So these all are based on that quotient rule. Okay, question number 5 and 6. You should try these questions by yourself, okay? This is also by quotient rule only, because you can say u upon v type, okay? U upon v type. U upon v type. Here also u upon v type, u upon v type, u upon v type, okay? So you have to do this by yourself, okay? Okay, now let us come to the exercise 7.3. Here I am going to see question number 9. Find the differential coefficient. When they say differential coefficient, that means they want you to find this dy upon dx, okay? Okay, last year I had also told you that dy upon dx is also written as y dash, okay, or sometimes here y1, okay? So don't be confused with that. And sometimes they write like this also, okay? Let's say y is equal to fx, then in that case dy upon dx or f dash x or y dash, same thing, okay, all equal, and this is only called differential coefficient dy upon dx. So we will do this question number 9. Here it says find the differential coefficient of each of the following. Let's see the first one, okay? In fact, this question is very easy. One can just give me the answer by looking at it. Like answer for this will be 4 times x square plus 2x, then again into, in bracket you will get 2x plus 2. This is the answer, okay? But for this you have to know the formula properly, okay? Then only you can write in, just you can do it mentally. Now we will see how we are going to do this. Okay, so this is the question. So we will use chain rule over here. So what we will do is we will write, let, see here we have x square plus 2x to the whole power 4. So what I will do is I will take this x square plus 2x as t. So let t is equal to x square plus 2x. Then y will be equal to t to the power 4, okay? So if you want to give this as equation 1, this as 2, okay? Now you can see that this function t, okay, is a function of x only, and this y is function of t only. So what we will do is we will differentiate this t with respect to x, because t is function of x. So we will write now dt upon dx. So differentiate this, so you will get 2x plus 2. I am doing straight, okay? Otherwise you can write like this, x square plus 2x, then again you can separate it, and then you can get 2x plus 2. So here I have written it directly, okay? So this is done, and dy upon dt. Why? Because now your y is function of t. So we will get 4t cube. Now put value of t, so you get this x square plus 2x whole cube. Okay. Actually, when I was trying to tell you that time at the beginning that I can do it directly, I think there I had forgotten to mention 3 in the power, okay? Anyway, so we got dt upon dx and dy upon dt. But we are looking for what? Dy upon dx, okay? So by chain rule, by the chain rule, dy upon dx will be equal to dy upon dt into dt upon dx. So dy upon dt is this, 4 times this to the power 3, and dt upon dx is 2x plus 2. So here you can see 2 will be common, so that 2 will come out, multiply with 4, so it will become 8, then x plus 1, and here you get this. Okay, so this is the answer. You can do it directly also, like if they are not saying, if they have not asked you to use chain rule, then you can do it directly also. Like here, this was your y, yes, y is equal to x square plus 2x to the power 4. So you know that formula, x to the power n1, yes, it comes this. So here what you will do is, you will think this whole thing as x for yourself, okay, think this whole thing as x. Then when you differentiate this, you will get 4 times, and this power will be reduced by 1. And then since this was not x, okay, this was a proper function, okay, so then you differentiate this. Then when you differentiate, you get 2x plus 2, okay. So directly you can get the answer. So unless you are asked for chain rule, okay, you should prefer doing it directly, okay. So you will get this. See, so this was done in 2 steps only, okay. Otherwise you have to assume something, then again you have to find this dt upon dx, dy upon dt, and then you have to use chain rule to get the answer, okay. So if you want to do it directly, you can do it directly also, provided you should understand, okay, and you should be able to get the correct answer, okay. See number 2. Here y is equal to log 3x plus 7. So you can do it directly also, otherwise you should do chain rule. So the question is, when you want to do it chain rule, how you are going to do? You have to put this 3x as t, okay. So you have to write like this, let t is equal to 3x plus 7. This will be equation 1, okay. Then your y will become log t, this will be 2. Then you have to find dt upon dx, because this is function of x, dy upon dt, okay, because this is function of t, and then you have to use chain rule, okay. Or what you can do is, straight you will write like it's given like this, log 3x plus 7. So you will write like this, dy upon dx is equal to, so directly you can write like this, and then you know the differentiation for log x, yes, you know that differentiation of log x is 1 by x. So what you do is, you think this whole thing, okay, as a single x, okay, think that this is a single entity, okay. So in that way you will get 1 upon 3x plus 7, then here multiplication, and now differentiate this 3x plus 7. So when you differentiate it, you will get simply 3. So this will be 3 upon 3x plus 7, okay. So if you use chain rule also, at the end you will get this answer. But the only thing, this chain rule will become very long for you. Like here, for the chain rule, first thing you have to assume, you have to put this as t, then y will be equal to log t, then you have to find dt upon dx, yes, which you will get 3, then you have to find dy upon dt, which you will get 1 by t, okay, that will be 1 by 3x plus 7, okay. Then by chain rule you will write by chain rule dy upon dx is equal to dy upon dt into dt upon dx is equal to dy upon dt, you have got 1 upon this, and then dt upon dx you have got 3, so you will get 3 upon 3x plus this. So you are getting same thing, yes, you are getting same thing, but you can see how many steps you have used over here and how many steps you have used for directly, okay. So whichever you find easy for yourself, you can go ahead, okay. See question number 3. So I will not do this question, I will just give you hint for this, okay. Hint, this hint is for chain rule, okay. If you want to use chain rule, then hint is what? You have to put t is equal to ax square plus bx plus c, and then you have to proceed, clear? And I will solve directly. So this question number 3, hint, okay, directly. I'm going to do it directly. So y equal to e to the power ax square plus bx plus c. You should try to do it, do most of the questions directly only, unless you are asked to use chain rule, okay. So dy upon dx is equal to e to the power ax square plus bx plus c. You know that differentiation of e to the power x is e to the power x, but here we have e to the power ax square plus bx plus c, okay. So just think that this is x only, think that this is x alone, okay. So in that case, what you should get? You should get e to the power ax square plus bx plus c. Then you have to put multiplication sign, and then you have to differentiate this separately and put it in bracket, okay. So you will get 2 times ax plus b, okay, where a, b, these are constant, okay. So your answer is this. This is the answer, okay. So better you get used to it, okay. You should be able to do it directly only, because when you get long questions, then you cannot waste your time using chain rule to solve this type of questions, which can be done just within seconds. Now see question number 4. Here this y equal to sine to the power 5x, this means actually y is equal to sine x to the whole power 5, okay. This means this. Now you can use chain rule also, or you can do it directly, okay. Better you do it directly, unless you are asked for chain rule, okay. So I can give you hint for chain rule, okay. If you want to use chain rule, then what you have to do? You have to put t equal to sine x. You have to put t equal to sine x. Done? Then you can easily do it. I will do it directly, okay, without chain rule. So for that, what you have to do is y equal to this. Now differentiate both the sides. So you will get this. Done? Now you have formula for this. Yes, x to the power x to the power n, you will get n into x to the power n minus 1. So what you do, just for a moment think that this is x, okay, alone this is x, clear. Then you will get 5 sin x, 5 minus 1 in the power, so 4, and then you differentiate sin x. Yes, now in order to differentiate this sin x, you should have formula. Okay, now let us see the formula. So here is the formula. The differentiation of sin x is cos x. Okay, so now here you will get 5 times your sin x to the power 4, and here differentiation of sin x will be cos x. Okay, so this is the answer. Okay, you will do it by chain rule. Okay, and you should see whether you are getting the same answer or not. Okay, so this is your homework. Wherever I am leaving hint, it's homework for you. Okay, question 5, y equal to e to the power cos x. This has to be this can be done by chain rule. Okay, so I will give you the hint. Put t equal to cos x. Okay, so when you put t equal to cos x, no, then you will get y equal to e to the power t and t equal to cos x. So here you are getting two functions. T is a function of x, y is function of t. You have to differentiate t with respect to x, y with respect to t. Then you have to use chain rule. Okay, that means for dy upon dx you have to do dy upon dt into dt upon dx. Okay, so you have to do that. I will do directly. See this. Directly. You will do it by chain rule. Okay, directly. Y equal to e to the power cos x. Now differentiating both the sides. Here you have e to the power something, yes, and we know that if we have e to the power x, then we get ex only, yes, and here we have e to the power cos x, but we know if we have e to the power x, then we get same thing, e to the power x. Okay, so what we will do is, just for a moment, you think that this whole thing is like x for you, think that this whole thing is like x for you, though it is not, but think that it is like x for you. So what you will get? You will get same thing, e to the power cos x only, because I am thinking whole thing as x, but since it was not x, it was cos x, so now I have to differentiate this cos x. Okay, and let us see what is the formula for cos. See over here, cos x gives you minus sin x, clear? So we have to use this. So here you will get e to the power cos x, and differentiation of cos x will be minus sin x. So your answer is this, minus sin x into e to the power cos x. Okay, if you had to do by chain rule, then getting only this answer, it would have taken 5 to 6 lines. Okay, so this is done. Now see question number 6. So here is given y equal to under root log x. So can I write like this, y equal to log x to the whole power half? Yes. Now things will be easy for us. I will leave hint for you for chain rule. Okay, if you want to use chain rule, then put log x, put t equal to log x. Okay. So in that case your y will become t to the power half and t will be log x. So you have to differentiate this t with respect to x, y with respect to t, and then you can use chain rule. Okay. Now let us see directly. Actually indirectly also we are doing chain rule only, okay, but we are minimizing the steps, that's all. So you can try this by yourself and check whether you are getting the same answer or not what we are getting through direct. Okay, so see, directly without chain rule. So y equal to log x to the whole power this, clear? Now differentiate both the sides, dy upon dx is equal to this. Now you have one formula like this where in power you have number, okay, you have a formula where you have one function, okay, and there you have in power a number, okay, then you get n x to the power n minus 1. So here also you get to see something like that only, that you have a function, okay, and then in power you have a number, okay, but the problem is in formula we have x over here, but here we have log x. So what you do, just for a moment think that this is not log x, this is x for you, okay, this is x for you. Then what we will get, we will get half log x to the whole power half minus 1, means you will get minus half, okay, and then differentiate this log x. Clear? So you get this. So this is half, so you will get down over here under root this and log x 1 by x. So you get 1 by 2x into 1 by this, okay. See question number 7. This question can be written as like this: y equal to x square plus a square to the whole power half, okay. Now you can use chain rule, and for that I will give you a hint. Put t is equal to x square plus a square, okay, then complete it by yourself, okay. Directly if you want to do, then you have to write like this: y is equal to x square plus a square to the whole power half, differentiate both the sides, then copy this one. Now do we have any formula where we have something here like as function and then in power number? So yes, we have one formula. This is the formula where you have here function and then in power you have a number, yes. So but here we don't have x, we have something else, yes, though in power we have a number, but here we don't have x exactly, we have something else, so no problem, think this as x. That's why here for the chain rule, no, since we are going to use this, okay, since we have to use this, that's why we are putting this as t, okay. Like here you can see I always say that think as a single x, yes, that's why here we have to put t, okay. So here think as x, just for a moment think it is x to the power something, then what you should get, you should get half and whatever is here you have to copy, and then in power you have to reduce, that power has to reduce by 1, so you get minus half. Done. But since this was not x, okay, so we have to differentiate that separately, okay, and whatever you get, that should be multiplied, okay. That's why we put multiplication sign, okay, because in chain rule also you observe the same thing. What do we do here? Once again, dy upon dt into dt upon dx, okay, getting it? So this is the, here like in chain rule what we do, we put this as t, as single term, okay, and that only we get in first, okay. So same thing is happening over here. I'm taking this as a single, okay, single x, thinking as x only, and whatever I'm getting after differentiation I'm writing over here. Yes, so this first thing what you get is same as your dy upon dt, okay. Now half x square plus a square, so this is minus half, so this will go in denominator, so you get this x square, and here when you differentiate you get 2x. A is constant, so 0, okay. A square, a is constant, so a square is also constant, so differentiation is 0. So this 2 and this 2 cancel, you are left with x upon under root x square plus a square. This is the answer, okay. See the next question. Here y equal to log 10x, okay. So here we have a formula for this log x, okay. We have formula for log x, but in our question this is not only x, this is tan x, okay. So this should be only put as t, okay. One second. We have formula for this log x, okay, but in this question here we don't have x, we have log tan x, okay. That's why this whole thing should be put as t, this whole thing should be put as t, okay. So I'll leave hint for you. If you want to use chain rule, then you have to do it like this. Hint, put t equal to this, put, okay, don't use t, use z, z is equal to tan x, and directly if you want to do, okay, so directly you can do like this, y equal to log tan x, differentiating both the sides, so log tan x, but we know that log x is 1 by x, yes. So if you have x over here, then we can easily write 1 by x, but here we have tan x, so no problem, think this as a single term x, okay. So you should get 1 upon x, that means 1 upon tan x, clear. But this was not x, tan x, so we have to differentiate this tan x, yes. Now you have to look for formula for tan x, okay. So tan x, I'm looking for the formula for tan x, okay. So here we have differentiation of tan x is given by sec square x, so we have to use this, so we get 1 by tan x into sec square x, okay. So you got sec square x upon tan x, this is the answer. Okay children, so I have done 1, 2, 3, 4, 5, 6, 7 and 8. Now 9 homework, try by yourself, either do it chain rule or directly. Okay, homework, 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 homework. Now if you get only these question, okay, then in that case better you use chain rule. But suppose you are solving some other question and in between you get while solving you get this something of this type, okay, then better you do it directly. But if only this question is given, let's say you are getting 2 marks, then that means they are expecting you to do chain rule. Okay, but when you're solving any question and in between something of this type comes, okay, then do it directly. Okay, don't waste your time doing chain rule. So I have already explained you like how you are supposed to do chain rule, okay, using chain rule, and I have shown you directly also. So you should do this, okay, directly, and you can do chain rule also, no problem, but better you try to do it directly, okay, and see whether you are able to do it directly and able to get the correct answer or not. Okay, and make sure that after doing this question you send me, okay, so that I can see and I can do the analysis of your improvement. Okay, I can, that way I can come to know that whether you have understood it or not. Okay, and the formula related to trigonometric and inverse trigonometric is already available in your formula list, so you can use from there. Okay, so this is all for today.